in a bit of a better way.
Would it be all right if I leave the Teams call so it doesn't come through twice?
That's absolutely fine, yeah, because I'm doing it all through Allspace. The Teams call's only there just for people who can't access it on here for whatever reason. Okay.
All right.
What I'll do is I will. Hold on, I'm just trying to work out what I'm going to.
I need to have my microphone on. By LJ, I won't be able to hear you. But what
I'll do.
Yeah, hold on. I can't. Oh, I don't.
Yeah.
Sorry, hold on a second. I'm going to turn my volume right down to 0. So hopefully there won't be too much of an echo on Teams as well. I'm going to stand over here. Okay, can you all see me okay? Yes, hope so. Right, what I'd like you to do, I would actually like you to line up 3 people, 1, 2, 3, first of all, in front of me. Don't matter which 3. Wow, that will do nicely. Okay. First thing we're going to talk about today is secure socket layer. Yes. How can I help? Put your hand up.
Oh, is that right?
That's what that is, yeah. Don't worry, it is a way,
but it means you put your hand up so I can answer your question, etc. as well.
Okay, so what we're going to do first of all is we're going to look at secure socket layer, or SSL. Okay. What do people know what SSL means at the moment? Anything? Oh, someone's got to talk up a bit. We did do a bit of it last week. It's a bit quiet, that. What it's to do with? Can you hear me okay? Actually, I better just check. Yeah, you're nodding. Okay. He's just going to stare off into space now, doesn't matter. Right, okay, yeah. Looking around. Right, this is how secure socket layer works, okay? Fingers crossed this is going to work as a good demonstration. And this is one of the reasons why I wanted to do it here. I'm just going to drop my laser pointer over here for a moment. Right, imagine that I am a server, okay? So, hold on, who's that over there suddenly appearing? Hi, Casper. Do you want to come over closer, come join us? We're going to do secure socket layer. Okay, so we have our 3 aspects of secure socket layer. That's what we're going to cover, okay? So, let me start by...
It's gone back to where it was. Let's pick it up from here. We'll have to go a bit closer to it. Okay, so
here is my server, okay? First of all, so yeah, the server is nodding. What's going to happen is a message is going to be sent from a computer to the server, okay? So I don't actually know who's in the middle. Who are you? Purple Skin.
Jake.
Hi, Jake. So I don't know if I've got no names coming up above your names at the moment, above your head. Jake, can you go from the client, which is over here, and you're going to be the message, that's it, and you go over to the server. And that is how a message is sent from client to server normally. Yeah? Is that all okay?
I'm okay because Kane's got a hat on. Kane, if you can come down here,
come and join us. Yeah, Casper, if you get closer. That's my virtual camera that's next to you, Casper. Right, now, Kane, you're going to be the secure socket layer. Okay, so what's going to happen now? Instead of sending the you're going to merge together like that. What actually happens, Kane, if you sit over at the server, first of all, that's it. And Jake, you're over at the message. So, the client needs to send a message. The first thing it says to the server is, "Hi server, I need to send you a message. Can you send me a secure connection, please?" So he sends through the secure connection, which is Kane, over to the person. There we go. Perfect. And now the message goes inside Kane. Now There you
There
go.
you go. Very good.
Now, Kane, you are now locked. The only person who can unlock Kane is the server. Okay? So he is the secure socket layer. No one can unlock that message, not even the client, once it's been put in. So Kane, see if you, or so if both of you, Kane and Jay, can move across to the server now. There we go, there we go, there we go, there we go, there we go. Okay, and now the message can be unlocked and the server can see the message. And then they can then have a box from the clients to send the response back in. Does that all make sense to everybody? Yeah?
Yeah.
So it means you've got like a box that you store encryption data in that allows you to actually only allow one person to see that data, i.e. the person with the combination on the box, which is the server. This is where there are the two keys. Very good. It is... I can't actually reply while holding a laser pointer. I can't close the message, sorry. You're right, that's where you have two keys. It's known as a public key and a private key encryption. Okay? Now, Casper, you are going to be an evil person. I'm sure you've never been an evil person in your life. Okay. So, you need to... whose server? I don't know the names because I can't see your names above your avatars. Who's playing the server? Is it you, Jason? I don't know. Yeah, is that Jason? If you can move further across to the end here, over by the lectern. Thank you. Right. So, Kane, can you be inside the server again, please? And then can Jake be inside the mess? There we go. Okay, Casper, can you stand in the middle for me? Now, this is known as a man-in-the-middle attack. Okay? So what happens is the client behind you, Casper, says, "Woohoo, can I have a message, please? I need you to send a secure box." And Casper hears it. So now Kane, the secure box, starts to go towards the client, but he gets stopped by Casper. Okay? Now, Casper replaces the Kane from the server with his own version of his Kane, which I'm going to call Evil Kane. So you're now Evil Kane. If you continue on to the client to collect your message, so this is actually Casper's box, not the box from the server. The message goes inside the Evil Kane. Okay? Now, the only person who can unlock it is actually Casper this time, not the server. So, Kane, if you go towards Casper with your message to Jake, if you come in as well, there we go. Casper is able to unlock this box and see what the message is. But not only that, he has the open box from the server, the good Kane. Kane, if you come and play good Kane now and be on the other side of Casper, there we go. So what Casper does now is read the message, is he puts the message inside the good box. So message, if you go inside the good box, now the good box goes back to the server, along with the message, and they go back to the server, which obviously unlocks the message and sees what the message is and sends the response back. So now, neither the client or the server actually know that they've been attacked in the middle. Does that all make sense to everybody? Yeah? This was a very, very specific man-in-the-middle attack known as Heartbleed. And it's all because Kane here actually has a name. He is either good Kane or evil Kane. So when the server sends Kane across, he should say to, "You're expecting a box called good Kane." And when the client, so when Kane goes over to the good client, or goes over to the client, Kane, do you want to go into the client? The client should ask Kane, "What's your name, please?" And Kane says, "I'm good Kane," and therefore he puts the message inside Kane. However, if he was evil Kane, it'd say, "Oh, you're not the right client. I can't send a message to you." Does that make sense? However, that message was not spoken. Oh, who's this? It's just joined. Oh, it's Zai. Hello, Zai. Right. The problem was our connections weren't asking that question. They didn't ask where this box came from. So it meant that the secure socket layer was actually breakable. And this was being used by the American government through a system called PRISM. Does anyone know who it was that discovered PRISM and released it to the wild and let people know that this was going on? No? He's a famous guy who whose name actually escapes me now as well. Which really, famous hacker, American hacker. What's his name? I can't remember his name either. Anyway, famous hacker. His name will come back to me in a minute. Begins with an S. Anyway, he's the one who revealed it, but we didn't know how it worked until another hacker, a white hat hacker, found the flaw. And when he found the flaw, he wrote to every single company and said, every single IT company, you have a flaw in the entire network of the computing system on the internet. This can be done by anybody. This is how it works. We need to fix this before I reveal it to the public. And that's what they did. Every company, Microsoft, Google, Cisco, every browser company, every hardware company, all got together and spoke together and decided to make the fix. And then they revealed Heartbleed to the world the day after the patch had been applied. So this attack, this man-in-the-middle attack, doesn't work now because when you check, you actually check the box and check to see if it's an evil Kane or a good Kane before you actually send the message. And that's how Heartbleed was stopped. And it meant the American government could no longer hear exactly what was being said by everybody. Does that all make sense to everybody? Fingers crossed. That is how Secure Socket Layer actually works. It's a box, a key, that's sent from the server to the client, and the client will send a box to the server to put the response in. So that the only people who actually have the key is either the server or the client, depending on where that box came from. And it's known as public-private key encryption. Does that make sense to everyone? Are you okay, Zai? Because then you missed the beginning of that. That's nodding his head slowly, but that is nodding his head. That's good. Okay. So that's one of the reasons why I wanted to do this in here. We'll do it again later as a demonstration when my line manager gets in around about 2 o'clock. He'll be joining on Teams rather than on the VR system. So I need to keep an eye on when he joins, because it's not probably that long, 20 minutes yet. Right, the next thing I want to talk to you about is some of the things to do with programming, variables, etc. Because again, we can use this. And what's really useful is, hold on, not me teleporting on top of item there. I wanted to actually drop my laser pointer. Right, we have Jake, and we have the server, which I believe is Jason, is it? Yeah? Right, you are perfectly positioned at the moment to be an example of what is the difference between a class and an object. Does anyone know what the difference is between a class and an object in programming? No? Yeah? Who's that over there says yes? Hi, shots. What? Oh, that's my laser pointer moving back. Okay, so what's the difference between a class and an object? Are you typing your answer, or are you going to say it out loud? No. Just a few more seconds, and then I'll start talking. Okay. Right. Oh, a class is the type, whereas an object is the specific. Very good. So here we have two objects that look like they've been based on the same type. I.e. they're both wearing red jackets, blue trousers, they've both got beards, and both got hats on. But they have been able to modify themselves slightly to be a separate object. So a class is like a blueprint, whereas the object is the actual created item from that blueprint. So if you like, we are all objects based on the avatar class, but we have two classes here that are quite similar. Does that all make sense? Yeah? Wow, we're actually getting somewhere with this. Now, we're going to look at some of the other aspects of programming. I've got to take my Visor application to see what's on my list. Functions and methods. Okay. Every object we have here is made up of a series of data and code that can run about it. So the data that's on this laser pointer at the moment is where it is in 3D space, so where you can see it, whether it's switched on or not, so to show the laser or not, but what code you think might run inside it. Any ideas? What programming code might be inside this object? Someone typing, you'll see words that suddenly appear by magic. but I'll carry on talking as well anyway. The code will be to switch on and switch off the laser, to be able to drop the laser, be able to pick up the laser. Oh, there we go, pick up the laser. And also to reset the laser if it's left rolling around for so long. Okay? When button click send light and drop and pick up. Very good, Kane, yeah. So those are the codes that make up the they're the codes that make up an object. An object is made up of variables and program code. So all of us right now are made up of variables and program code. We have code that allows me to teleport from one place to another. Like something turn behind you. There you go. So you can find me. But I also have code that I can move my hand. But I also have variables. So my hand is actually stored in 3D space. I need to know where in 3D space it is, the X, Y, and Z values. I need to know where my body is in 3D space. I need to know where my head is. Obviously, because I'm
viewing from a virtual
reality visor, I need to know where I'm looking as well. My camera. I can turn my head from side to side to get a different viewpoint on things that you can't necessarily do if you're on a standard computer. So all these things are quite important when it comes to programming. Anyone got any idea how this entire environment was made? What programming language do you think this was written in? Any idea? I'm going to move over here. You don't have to join me just yet. Okay, because I'm going to build something for you in a second. Okay. This was built in Unity. This entire environment is using the Unity 3D engine. And it's been built exactly into C#. So this shows you an example of you can actually build things like this in C# yourself. Now what I'm about to do is add a new object into this world. I have complete control over this world because I created it. So I'm going to create something. Ready? Let's move it to here. There we go. I may need to step back so you can see the wonderful world which we live in. Well, this actually is a complete representation of the solar system. As you can see, we've got Mercury flying around the sun. Venus runs quite quickly as well. And then you've got Earth coming just past my head here. You'll see Earth. I know on the camera it's a bit different. You can see it from a distance. If I go and get the laser pointer, I'll point out, obviously. They're all labelled, so you should be able to work out what's what. You can turn off edit mode as well. I'm still edit mode at the moment. Right, so you've got the sun in the middle. And then you've got an animation going around of Mercury, Venus, Earth and Mars. And you can see some of the differences between the way that the planets actually move. So Earth has quite a fast spin, as you can see, as does Mars. But if you look at Venus, Venus is moving. Oh, I've just got Jupiter coming into my place. Venus doesn't appear to be spinning at all. Now, the interesting thing about Venus is its day is actually longer than its year. It takes longer for it to spin round once than it does to go all the way around the sun in one go, which is quite cool. We've also got, hold on, Saturn's coming up just behind me. We can build a 3D model like this into our classroom and build it and actually show people something we want to show, something that we want to examine. So it becomes so much easier. If I just stopped it, or I just that's the animation resetting. It becomes so much easier to actually to explain concepts if you can see the concepts actually on the screen. Now I'm just going to get rid of the solar system for a moment. And what I'm going to do is I'm going to replace it with this. Now I'm going to just bring it down onto the floor level. Just wait a second while I move it around a bit. I'll put it over here. Now, does anyone have any idea what this might be? You want to come over to it? Can the camera move as well? There we go. Right, what do you think this might be? Any ideas? Noughts and crosses, it is indeed. Yes, you can actually play noughts and crosses, and you play it as a group. And whoever wants to put the first piece down can just literally stick the first piece down. The next person can alter it. So again, it's an interactive environment. We can actually create things, fingers crossed, where we can actually have interaction. So you can create levers and switches and all sorts of other things that you can then actually utilise in this world. Now, how many people think that this is preferable to teams? You can either put your hand up, you can nod your head, or shake your head if you think it's not preferable to teams. What do people think? Do you think it's preferable to teams? You can play Cards Against Humanity. Yes, you can. There is a Cards Against Humanity game built in as well. Some of you may have already come across that by playing with some of the settings today. Let me see what else I can find for you to wear a hat. I don't know what wear a hat does. Hello World is the first functional item. What I can do, you see, I can write my own items. And I can then put them in. So hold on, what's this? Alien planet. Let's put an alien planet in. Where's the alien planet going to go? Let's put blue drop in. It's not actually good. I think they're too big to actually. There we go, there's a blue drop. I can grab things from other universes and I can then move them around. These are some things from alien planets. But what's even more fun is that we can actually teleport from one place to another. You don't have to stay in the classroom, you can move from other places. Let's go back and find some other objects. Let's have a button. Let's have a camera button. There you go, the camera button. So there you go, you can have a camera, and I think if I come out of edit mode, a helpful message, okay. So I can then program this with a message and make it say something else. Except I haven't done that yet because I need to actually go into my world editor to do that. And I can build this up as I'm going along, as you can see. Let's get the button. Let's see what the button says. I can change the settings. And I could say, what should we do is the dialogue text. Let's say, hello, class. Now, it just looks like I'm looking at my feet and things. I've got a keyboard. So now, if someone presses the button, it now says, hello class, hopefully. Instead, yeah. So actually, what we could do, now can anyone else actually move things around? I'm guessing not. You can't grab any of these items, you can't edit it because this is my world. But what we can do is that we could actually have a memory store. Okay. So what I mean by that is, if let's go round over to the other area. Okay, so let's come out of our classroom. Let's go to the more nice area. This is the sort of the warmer area. So we have a lot of like keep the mic volume instead of actually turning around. I have to sort of turn around with the controller rather than turn around with my head, because otherwise I get confused where I am. So what we could do, for example, is we could actually add new buttons that do new things. Like, for example, we could have let's add a question button. So I'm going to add a question button into alt space, and I'm going to move it over to here. And then I'm going to alter the question button, and we can write our own text in here. So we might have like a variable. I'm breaking up. Variable equals box to store data in. To store data in. And then I can move out of edit mode, obviously. That's the editor. Now, at any point when you need to remember what a variable does, you can go up to that button and you can actually understand it. and we can have different buttons set up all over the place for different terminology, so that you can actually start learning terminology based on where it is in the 3D world. Because we are very good at doing things in 3D. As human beings, we're designed to work with 3D. So it means that we can start placing things in a 3D location. Oh, thank you very much. Someone's brought me the pen. I can't actually collect it though. Where's it dropped? Oh, it's gone, missing, hiding away. I have to go and get it in a minute. Now, I don't know if you have. Now, you might not have the ability to do this in here. It used to be that AltSpace gave you the ability to have browser windows. So I could actually set up a browser window and we could all look at an internet page together, which means that you could all look at my iPad, my laptop screen, for example. Hey, go take a selfie or take a photo. Yeah, you can take photos as well. You've got cameras and things, so we can get everyone coming in. There we go. That was bad. I just took a photo. Should we all get in for a photo then? Should we all come into, or if we all stare around, we can all come in for a photo. Everyone all in? Or let's move it back further. Oh, I'm doing photo rather than selfie, so I press the wrong button. There we go. Selfie. The selfie camera's not working. Well, there we go. Hopefully. There we go. Yeah, we almost got a whole entire class. Look at that. You can actually start making memories. I mean, I don't think any of you have ever read any fiction, but there's a thing called a memory palace, which is where inside your head you create your own 3D world almost, and you put things in different locations to help you actually remember where things are and how to do things. And you can do something like that for real here in virtual reality, in AltSpace. So when you want to, you can actually, if you click on the settings, don't do this now necessarily, but the settings of AltSpace allow you to open up a beater, which allows you to create your own worlds, and you can create your own universe as well. And when you create your own world, you can then actually create your own buttons and things in a location, and other people can then go and visit. So you can actually invite other people to visit by adding them to a whitelist, like I did for this classroom. So not only does it mean that, for example, I could be anywhere right now. I could be on a train, as long as I've got an internet connection in my virtual reality advisor, which isn't connected to my PC, by the way. This is a standalone device. It's not Oculus Go, so it's a discontinued model now. But I could be anywhere talking to you while I was on a train or something like that, and actually have a virtual classroom set up with everything that we actually need in the classroom to actually be able to do. Yeah, does that all make sense? Now, hold on 1 second and just see what time it is. Right, I'd like you all to just wait here for a minute while I go and set up something in the other room. Just wait there, and I shall be back in a few shakes of lamb's tail.
You guys want to see a magic trick?
Go for it.
I don't know. Feels so good.
Stop peeking. Okay, you can all come through now. Not going to be very exciting, but come through. And you'll see there are some orange buttons on the walkway, okay? I want you to see what all those orange buttons say first of all. Okay, so go and click on all the orange buttons and find out what they say. It will come through. Okay, we all worked out what all the different buttons say. It's going to be even more fun now as I'm going to move them.
I don't know if it's like this for anyone else, but Chris, you keep cutting out.
Do I? Do I keep cutting out? Sorry. I don't know if that's my internet connection or not.
Yeah.
Do I? I'm still cutting out, am I? If you go onto Teams, I'm on Teams as well. If you want to listen on Teams on headphones or something like that, so you should be able to hear me better on there. It might just be this is cutting out because of the connection. I might. Is that hopefully this will be better? I've just turned my mic volume up as well, so hopefully it's not automatically turning off silently. Is that okay? Can everyone hear me now? Okay, what I'd like you to do is I'd like you to find the orange object and stand next to the orange object where you would store numbers in. Okay, what would you store numbers in? So move towards the orange object that you would store numbers in. Oh, you can't hear me. Okay. What would you store numbers in? Okay. If you move towards the orange box that you would store numbers in. Any ideas? Stand right next to the button that you think is where you might store numbers. Stand right next to the button where you think you might store numbers. It is a variable, yeah. So what? We can't hear you at all. We're cut out completely. Can you hear me on Teams? Can you hear me any better now?
I can hear you on Teams.
Yeah, you can hear me on Teams, okay?
Yeah.
Open Teams. Okay, I'll say open Teams. Let's send that as a message to everybody. So hopefully they'll see. I'll send them a written message on Teams. Hold on as well. If you can hear me on Teams, that's okay. Let me just put this in the chat window. Yeah, 3-year 1. Right. Crackling and still have no sound. I don't know if that's to do with AltSpace's connection, because I've got it open on another window and it's working okay. I can hear myself on there. So I don't.
I can hear you on this. I can't hear you.
You can hear me on Teams. Okay. I'll carry on talking on Teams as well then. Obviously I'm on Teams anyway.
Well,
So if you want to listen through on Teams, you can hear me there. You don't have to be listening to me on AltSpace. You can turn off your I was going to say, how can you turn off your speaker on AltSpace if you're on the same device? You might hear me in stereo. What I'll do, I muted myself on AltSpace, okay? So hopefully you can still hear me on Teams, is that right?
Yeah.
Can you all still hear me on Teams, okay? Yeah? Is everyone else still listening in on Teams as well? Okay, that's fine. Right, can everyone still hear me though? Are you all connected on Teams to hear me using Teams? Yeah? Anyone not connected? Right, okay, so yeah, what I'd like you to do is go to the orange box. There's where you would store a number, okay? What would you store a number in? A variable. Okay, so where can you find variable? Is variable one of these?
I have no idea because I'm not there anymore because I couldn't hear you.
Oh, yeah, you can't see, that's fine. Variable doesn't appear to be one of these, so what might it be if it's not variable?
A string. Would you have it classed as a string?
It's not string.
Would it be an object?
It would be an integer, where most people are now moving towards. An integer means a whole number. Okay, so that's where you would store a number inside an integer. It's a data type. Can anyone find where's data type on here? Data type is over here, is it? Up there. Yeah, it's up there. That's where data type is. Okay, so that is an integer is an example of a data type. It's a type of object, so a type of variable that only stores numbers. There is another data type listed here as well on one of the orange boxes. So can anyone guess what the other data type is that's listed on an orange box?
String.
Okay, if you go up to it.
I'm not there.
Going to be. It is string, and yes, you are all gathering around it. Very good. So string is another type of data type. What do you store in a string?
Words.
Words, writing, text, and characters. Very good. Okay. Which one of these of these orange circles represents an example of a blueprint for an avatar? So the basic idea of an avatar.
Object.
Not object.
Ah.
Everyone's moving towards it
It would be
correctly.
the class.
It is
Class.
the class. The class is the blueprint which we use to create something else, which has now just been said.
Yeah.
And that's the final orange block to find. Because you've all ended up going down there anyway. Yeah, that is an object. Nice and easy. Okay. So, it was a very, very simple demonstration of how we can actually do things like making almost a game out of just understanding some of the concepts and things that we've got. Obviously, we can zoom around as well. The next thing I want to do with you, if I go into edit mode, just one moment so that you can not see. Okay, I want you to read all the messages again, all the orange blocks, okay? They might start moving. Right, I'm going to remove one of the blocks. Hopefully. Right, okay. Which one's missing?
Is it data type?
Sorry, say that again.
Is it data type?
Data type? Is data type missing?
Yeah.
Yes, you're right. It is data type that's missing. Well done. So again, we can use this as a way of doing memory tests and etc. as well. What we can do is hide things in different places and see what you can come up with, for example. And you can see, I can move things around, hide things, see if you've actually remembered all the different bits of information that we've actually covered. The idea being that this should stick in your mind a bit better than just saying it out loud in some sort of simple sort of lecture style theatre, which no one ever learns anything anyway, because people can't just walk around and move. So let's do our SSL again. Does someone else want to talk through the process of what a secure socket layer actually does? And you can use different people as to demonstrate.
Sure. The basic version. Sure. The basic version of an SSL would be between a client and a server, so a computer and a server. So the computer would send a message to the server saying, "Can I send a message to you?" The server would send a sort of a bodyguard or secure link back to that client computer, and then that message would then go into the secure link and then back to the server and have that.
Exactly. Well done. Very good. So you've got this double connection where you've got a public key and a private key, and only one of the devices can actually open it through. So it shows, I hope, that do you think you've learned that better by doing the demonstration that we've done in here than just talking about it in Teams?
I always learn better by being shown, so I would imagine learning better in virtual.
That's very good. Okay. Oh, hold on. Stephen can't get into the session. Invite him into the session. Hold on one second. Oh, I guess he's not a member of this group. Hold on one second. I'm going to just have to add the group as well. Sorry, just 1 second, everybody. Where's groups? 3-1. Manage members. Right, now added him in as a group member. So now hopefully I should be able to ask to join. There we go. Let's see if he comes in. Hi, Stephen.
Hello.
Yeah, you weren't able to be added because you weren't a member of the group for some reason. So just added you in now. So now hopefully you can see where we are. Obviously at the moment we're all in alt space. So this is what it looks like. I'm the guy with the beard, which people have got beards in here. Doesn't really make much of a difference. Right, we're just talking about how we could do SSL, and we did a demonstration of SSL, a secure socket layer, rather than just talking about it in Teams. We actually did it as a moving group of people. Shall we do the demonstration again, guys? Do you want to get into position to do a demonstration again? So, Jake, do you want to be the message packet? Yeah, should we go back to the front of the classroom to do this? Okay, so who wants to be the server this time? Casper, do you want to be the server? Have you come over to by the podium? Okay, Zai, do you want to be the security box? So if you come over to the server. And who else have we got?
Who's the server?
Shall I be the client? I'll be the client. Okay. So I'm the client, and Jake is my data packet. Okay, so I'm going to ask the server, hey server, can you give me your secure box, please, to be able to put the data packet into? So the secure box then comes through Zai. Jake, you can go into the data packet. But as soon as I close Zai, the lock on Zai, you're now an encrypted data packet that no one else can access, apart from the server, not even me. And now you can now travel across safely over to the server, knowing that nobody can actually get hold of you apart from the server itself. And we showed an example of how Heartbleed works, which is a man-in-the-middle attack that no longer can happen, thankfully. The next thing I actually want to talk to you about is methods and functions. Okay, so just wait for the clock to finish ticking. It's a delayed clock. Right, we talked about objects, and we talked about the laser pointer as an object, as an example of something that has both data and information in it, and how it has some program coding associated with it as well. Now, does anyone know the difference between a method and a function?
The method is how a function is done. So the function explains what you want the function to happen, or like say you want to move forward, and the method explains how that function is going to happen.
Very good. You're almost there. The method isn't quite right, but the function is. The function is a piece of computer code that just runs through a specific job, a specific task. So that is a function. In mathematics, we talk about functions as returning something. For example, if I have two people and I want to add them together and make another third person, that's a function. Okay, taking two numbers, adding them together to make a result is a function. A method and a function are actually the same thing in computing, but for just one different fact. It does not return anything like a function would. So sometimes you can have a piece of code that doesn't actually return something to say it's happened. It just does something, like turning on the laser pointer. The code turns on the laser pointer, and you can see it can actually go in your eyes and things like that in your cameras, over like that. But all it's actually doing is turning that laser pointer on. It doesn't have to return to tell me it's turned on or not. It has no returning function. Mic drop. Very good. So A method and a function are basically the same thing. They're a piece of computer code, only a function returns something, a method does not. Okay? Is that all okay with everybody? Yeah? Do you understand that? Yeah? Cool. It's very, very simple that we use them interchangeably all the time. We might talk about methods when we mean functions, functions when we mean methods. If you do things with JavaScript, everything's a function. There's no such thing as a method. So we get things used in, and the only time you really need to know whether something's a method or a function is when you're writing about it in your assignment brief. Okay? Something else that we talked about last week that I asked you to do some research on was encapsulation, polymorphism, and inheritance. Do you all remember those? Can you give me an example of inheritance that we can see around us right now in this 3D environment? Any ideas?
Would that be like the base of the character design? So everybody has a base of a character design.
Exactly. There is the same basic character design is used for everyone. So you're inheriting a basic character design. However, you may notice actually that my character design is slightly different from yours. I have a hand I can wave around. Why is that?
Because you have VR controls, so you'd the
I've got
VR.
VR control. So I can tell immediately if someone is like a PC, their hands are down by their sides, or they're using a VR system like mine with one controller. I have one hand I can use, or there are other VR systems that have two hands that you can use, so you can actually move things from hand. Okay, is that an example of something else? The three things are inheritance. Something just dropped. I could hear it. Encapsulation and polymorphism. What's this an example of? Any ideas?
Would it be?
It is polymorphism. Very well done. Because we're talking about completely different systems here. I've got a different system to you guys, so I'm a complete different type to you, but we've actually been based on the same inherited type, just with added features added extra, and that's polymorphism. Okay? So what is meant by encapsulation? What aspect of what we've talked about today is encapsulation?
Wouldn't that mean that everything that we've just talked about is all put into the same program, so everybody can use it on the same sort of version of platform? Like it's all encapsulated together.
Encapsulation just means literally like the English term, encapsulating things. So in computer programming, we're talking about each object encapsulating both data and code. So you as an object are currently encapsulated. You are able to pick up objects. As people now trying to go on, you need to move your head raise your head upwards, so you're facing the ceiling, and then try and drop the microphone. There you go, drop it. Then just swallow it. There you go, and you're able to actually throw the microphone up into the air. I can't do the same thing because of the type of object that I've got. I can hold it in my hand, but I can't hold it anywhere else. I can't put it up and then drop, I don't think. It just then drops on the floor below me. So we have encapsulation, polymorphism, and inheritance. And these are the most important things to do with object-oriented programming. If it wasn't for object-oriented programming, an environment like this just wouldn't be possible, because the code to just alter each of the different people would be so complicated. You'd have to go through so many different lines and so many different procedures that it would be very, very difficult to keep track of. So by encapsulating things into objects, it's very easy to keep track of where all your code is that changes things to do with the object. So even the fact that you can change your visuals, change what you look like, change what you sound like, or change what hat you've got on, all of that is all part of object-oriented programming. Okay? So, final thing for the lesson. I'm going to go over to the window if you want to join me. Right, let's have one second. let's add a button. So I'm going to add a hash button this time, so a hash symbol. Okay. I'm going to move that over to here. So what we can actually do now is we can set this as what we've had as our first lesson. Editor panel, hash button. So discussion. On OO programming. And SSL. We've now got that in a set place in our world. So as we start adding other classes into here, we can make a list of all the different programs that we've done, and actually I can then reprogram those buttons to go to the video, for example, of where you actually of the video of this talk. So what I'm going to do, I'll do that offline so that once the video is actually online. So if you want to watch back the video of the entire lesson at any point, all you have to do is go back into AltSpa, come over to find which lesson it is by clicking the right button, and then click play on the video that's directly above it. Does that make sense to everybody? Yeah?
Yeah.
So this way you can actually, as I say, remember things in a better way, because we could have any lessons to do with object-oriented programming over here. We can move lessons over to where our orange buttons are, for example, for lessons that are to do with the website development. We can have everything to do with the internet side of things over in another section. Yeah, does that make sense? So very quickly you can actually find what you actually need to, easier than you can doing searches on Teams or searching through lots of names of videos, not remembering exactly when you actually went through that particular, or when I went through that particular piece of work with you. Does that all make sense to everybody?
Yeah.
Yeah? So do we think it's useful?
Yeah, visualization is a great learning tool. It helps me anyway.
Brilliant. Does anyone still think that Teams is
Yeah.
a better environment?
No, I prefer working the team.
You prefer this over Teams? So if we
It's
were to
more
do this,
engaging.
it is more engaging. I mean, it helps me as well, because obviously I can actually see you, and I can see you nodding, and I can see you move around. And I think that just that moving around, that action, means you're not just sat there in front of a computer screen just watching me talk, which I think as well does help. And you've obviously, because you're still on computers, you've still got the internet to research, etc., as you need to, and you can still see my laptop screen on your computer without having to look at it in AltSpace as well. So as I say, I'll finish the. So what I'll do, I shall put up the video for this lesson directly above this button. So if at any point you want to come into this world again, you should be able to come in, and I shall make it public so that you can find it again easily, so that you can all, you're all whitelisted, so only you can obviously come in, and we shall go from there. I've got another lesson with you, normally tomorrow, but tomorrow is actually the first day of half term, so you don't actually have any more lessons this week with me. So I shall wish you a good half term and a good weekend, and we shall meet back originally in Teams and possibly in AltSpace next Thursday. Not next Thursday, but the Thursday after. So the Thursday after half term. Is that okay with everybody?
Yep, see you then. Thank you.
See you then. Okay, I shall log out of here, but if you want to carry on walking around the world and having a play, you certainly can. And I shall just finish the Teams message as well. Okay? Right, guys, I shall see you all later. Bye-bye.
Thank you.